Hey, 20-2s. What we're going to look at in this lesson is we're going to look at simplifying expressions that have variables in them. All right. So because we're going to add in these variables, it will make things a little bit trickier. But let's see how this goes. So simplify each of the following expressions. All right. So the first one I look at, I'm like, oh boy, 1600, the square root of 1600 x to the power 4. Great. Okay, well, the first thing I recognize is, okay, I know what the square root of 1600 is. It's just 40. Hey, that's good news. But what would the square root of x to the power 4 be? Well, just remember, when I'm asking you to square root something, I'm asking you to find the side length. Well, what would my side lengths have to be that are the same that multiply to give me x to the power 4? They would have to be x squared, right? Just like that. So the square root of x to the power 4 is x squared. That's it. That wasn't so bad. If I asked you what the square root of x to the power 6 was, well, for these to be the same, they would have to be x cubed, like that, right? And so on and so forth. So it was x to the power 8. Your square root of x to the power 8 is x to the power 4. Hey, that wasn't so bad, was it? Okay, let's try the next one. Square root of 45, x squared, y2. Okay, well, this one, what I'm going to do is I'm going to say, well, 45 is 9 times 5. I've got x squared, y squared. Square root of 9 is 3. Square root of x squared is x. Well, square root of y squared would then just be y root 5. Done. Okay. Now, the tricky part about these things as well is that we can't put these in our calculator like we could the rest of the unit so far to check our work. Okay, that's what makes it a little bit more difficult. All right. What about cubes? What about when we have odd powers? The first two we did, they had even powers, x4, x squared, y squared. Okay. When we have an odd power like x cubed, I don't know what the square root of x cubed is. Because again, if I draw my picture, I can't make anything here with a whole number exponent, right? That's going to give me those side lengths. So we've got a small problem, but it's not a huge problem. So here's what we're going to do. Well, 20 we know how to take care of. That's 4 times 5. My friends, what we'll do for x cubed is the same thing that we just did with the 20. We're going to break it up into 2 factors that I can take the square root of, like that. So now I say to myself, the square root of 4 is 2. The square root of x squared is x. And I'm left with 5 root x. Just like that. Okay? So when we have an odd power, what we're going to do is to split it up into x to the power 1 and whatever else we would need here, but it'll be even because we can take the square roots of even powers. Let's try it again. 27 x squared y5. Well, 27 is 9 times 3. X squared is even. That's going to be easy. Okay, y5. I'm going to split y5 up into y4 times y1. Square root of 9, 3. Square root of x squared, x. Square root of y4, y2. What do I have left? A 3 and a y. And I am done. Okay, so when we have an odd power, what you're going to do is you will split it into x to the power 1 and then x to whatever we're going to have, but it'll be even. And then you can take the square root of that. All right, so there's your plan for that. But here's what makes this even trickier. The problem is, friends, is I'm asking you to take the square root of variables. And remember what a variable is. X here means it can be any number in the world. But we've got a problem. We can't take the square roots of negative numbers. right? I'll say that again. We can't take the square roots of negative numbers. The smallest thing we can take a square root of is 0. So what I'm going to say here is only non-negative things can go under here. So what I need to say is I'm going to say x is greater than or equal to 0. That's my restriction. That's saying I can't put negative numbers underneath that radical. Okay? Let's look at square root of x cubed. So again, I look at the x and I say, okay, what would happen if I stuck a negative number in for x? So say -2. Well, -2 cubed would be -8. I can't take the square root of -8. So once again, x must be greater than or equal to 0. X squared. So I say to myself, what would happen if I stuck a negative number in for x? So say -5. Well, -5 squared is +25, and that's something I can take the square root of. So any negative number that I substitute in for x turns into a positive because it's being squared. So that means I can sub in any number for x. So I don't have a restriction. What we say then is x is an element of the reals, of the real numbers. Meaning you can put in anything for x you want. One more, x to the power of 4. Well, guess what? What happens when I stick a negative number, raise it to the power of 4? A negative number to the power of 4 turns positive. So I can stick negative numbers in there. X is an element of the reals. I really don't have a restriction. So what I want you to think about here is if we have an odd power, we have a restriction because we can't take the square roots of negative numbers. But if we have an even power, that would make all our negative numbers positive. So we don't have a restriction. Okay? It's a little tricky, I know. Okay, what about cubes? Well, cubes are even easier, friends, because say I did this, cube root of -8. Well, the cube root of -8 is -2. You can take the cube root of negative numbers. So guess what? Cube roots have no restrictions. You can take the cube root of any number. So as soon as I see my index right here of 3, guess what? Boom, done the question. Okay, so where do we really have to watch out for? We really have to watch out for when we have an even index right there. Okay, so when we have that even index, you need to look at the power and say to yourself, is it odd or even? And then break it down from there. If it's even, you're in good shape. If it's odd, it's usually x is greater than or equal to 0. Okay, there it is, simplifying expressions with variables.